folks. This is the third and final video of dimensional analysis and conversions. I originally was going to only make two, but I noticed my students struggling with application concepts to this. So I wanted to add a few more samples and give you a few more hints. So once again, we have our prefix table here. Once again, we have how to set up a dimensional analysis as explained on the first two videos. And now here's some problems we're going to work. And we have our number line as well, because our number line can help us. Here's the first problem. This problem says right here, convert 6,230 millimeters to centimeters. Well, you know that milli means 10 to the minus 3, and you know that centi means 10 to the minus 2. So then I find students that they want to say, okay, so there's 10 to the 5th of the one into the other, but now let's think about this. Okay, and as usual, we're going to put down our given, and we're going to put down where we're going. Once again, if I have milli here, I'm going to place milli here, and I'm headed to centimeters. That's what I want. Remember, this will cancel with this. I'm left with what I want. Then my next rule is I give the one to the big one. Who's the big one? Well, a centimeter is bigger than a millimeter. And then students struggle to realize what to place right there. One's 10 to the negative 3, one's 10 to the negative 2, so what do I do? Well, they're only 1 power of 10 apart. In other words, it only takes 10 millimeters to make 1 centimeter. Now, if you look at a ruler, you can prove that to yourself, but sometimes we get so bogged down in the weeds, we forget to think logically. So it only takes 10 millimeters to make 1 centimeter. So I'm dividing by 10. In this case, 6,230 millimeters to centimeters divided by 10 is going to be 623 centimeters. Okay, so don't get so used to doing the hard stuff that you forget the basic easy stuff. Also, if your conversions are on the same side of the number line, just count how many places of 10 they are apart. Let's look at the second problem. The second problem that we're going to try says convert 8.69 megagrams to kilograms. So if I look up here at my prefix table, mega is 10 to the 6th and kilo is 10 to the 3rd. And then students want to have a conversion factor with a 10 to the 9th. But let's think about this. Mega is 10 to the 6th. Kilo is 10 to the 3rd. How many places are they apart? How many powers of 10 places are they apart? They're apart 10 to the 3 places. So let's put down our given. Let's put down where we're going. Obviously, because of dimensional analysis, whatever I have here, I place here. I'm left with what I want. And now it comes down to writing the correct conversion factor, which could be confusing for this set of units. Okay, first of all, who's the big one? Well, by now you should be quite comfortable knowing that mega is the big one. Mega to kilo, we just said that they're 3 powers of 10 apart, so it's going to take that many kilograms to make 1 megagram. Okay, so then I'm just going to multiply according to my dimensional analysis, and I'm going to get 8.69 times 10 to the 3rd kilograms. Done. Another type of problem that I find is throwing my students off is when there are units per a unit. For example, look at this problem here. Convert 3.8 kilograms per liter to milligrams per milliliter. All right, so now you have to convert a unit in the numerator and a unit in the denominator to a new unit in the numerator and a new one in the denominator. So go ahead and put down your given like before, except now it's kilograms per liter. So you're going to have to put kilograms per liter. So that's a little bit different. but the same principles apply. Let's put down where we're going. We're going to milligrams per milliliter. All right, so here I go. If I have kilograms on top, right there, I'm going to put kilograms down here. And I want to go to milligrams. So now I've taken care of this one. And for the liters, I want to take the liters and I want to make the liters into milliliters. So if I have liters down here, I'm going to make this liters, but I want milliliters in my denominator. And now I've got it right. So now I've set up my units correctly, because watch, the kilograms cancels with kilograms and the liters cancels with liters, and I'm left with milligrams per milliliters. So I've done everything right, but now I've got to write two conversion factors. Okay? In my first conversion factor, kilogram is the big one, milligram is the little one. Let's look at our number line. I'm going from milligram to kilogram. I'm going from milligram to kilogram. How many places is this? 1, 2, 3, 4, 5, 6. I'm going 6 places. So the conversion factor is 10 to the 6th. In the second one, I'm going from liter to milliliter, and by now you're very comfortable with this. Liter is the big one, milli is 1,000th, and it takes 1,000 to make 1. And this is now my dimensional analysis problem. So look what I have. I'm left with, when I look at my grid, 3.8 times 10 to the 6th over 10 to the 3rd. When I divide with exponents, I subtract. So I'm going to say this is 3.8 times 10 to the 6th minus 3. So this is 3.8 times 10 to the 3rd, and my units, milligrams per milliliter. Final answer. Now what if I had something with a squared in it? Centimeters squared to millimeters squared. So we're talking about an area now. This can happen with area, this can happen with volume, and then things get kind of confusing. So I'm going to show you how to deal with this. So once again, we're going to put down our given. That's grams per centimeter squared. And now we're going to milligrams per millimeter squared. We're going to follow the same procedure as we did up top. If I have grams here, I place grams there. My grams is headed to milligrams. I'm left with what I want. I got my milligrams down. Now I need to convert centimeters squared to millimeters squared. And so I had centimeters squared here. Place it there so they cancel, and once again I'm left with what I want. So now I place my units correct, and I'm very comfortable with making this first conversion. Milli means 1,000, but it takes 1,000 to make 1. But now I have the centimeters squared to millimeters squared. What does centimeters squared mean? It means centimeters times centimeters. And millimeters means millimeters times millimeters. Well, up above we just said how there was 10 millimeters in 1 centimeter. Okay, so then how many millimeters squared are there in 1 centimeter squared? Well, if it's squared, I have to square my number. So instead of writing just 10, I'm going to write 10 squared, because it's 10 times 10 to make millimeters squared. 1 times 1 centimeter squared, I can write 1 squared if I want, but we all know 1 squared is 1, so let's not. So the big, huge difference here, and this is something you may not have seen yet, the big, huge difference here is when this is squared, whatever your conversion factor is, it has to be squared. Now, what I'm finding students doing is when they see this, they want to do math with these units. Don't do math with those units. Those units have served their purpose to give us the correct numbers. and we've figured out and we're left with what we want. So don't do math with those units. They're simply units. Leave them alone. Leave those squareds alone, okay? This one canceled with this one. We were left with what we want, so we're good. Leave those numbers alone. So now what do I have? I have 7.86 times 10 to the third over 10 to the second. 3 minus 2 is 10 to the 1. So my final answer is 7.86 times 10 to the first milligrams per millimeter squared, or it would be appropriate to write 78.6 milligrams per millimeter squared. Now we're going to try a harder one. This one has cubes in it, but you'll be fine. Let's do it together. Here we go. 8.29 kilograms to millimeters cubed. .29 kilograms per millimeters cubed to grams per centimeters cubed. Who comes up with this stuff, huh? Okay, so once again, we know how to do this. We're going to set up our units. I have kilograms here. I'm going to place kilograms here. And I'm headed to grams. Boom, done. And now I need to take my millimeters cubed. That's kind of frightening to me. Millimeters cubed. And I need to go to centimeters cubed. Okay, so once again, these will cancel. Left with what I want. These will cancel. Left with what I want. Now I just need some conversion factors. The grams to kilograms one I'm completely comfortable with. And now I have millimeters cubed to centimeters cubed. What does millimeters cubed mean? It means millimeter times millimeter. It's a volume, right? And I know from previous examples that there are 10 millimeters in a centimeter. So that's going to be 10 times 10 times 10. So if I have 10 millimeters in a centimeter, how many millimeters cubed am I going to have in a centimeter cubed? Well, I'm going to have 10 times 10 times 10. So 10 to the third, or 1,000 of them. So in this conversion factor, I know that there's 10 millimeters in 1 centimeter. How many millimeters cubed? How many millimeters cubed are there in a centimeter cubed? Well, they're going to be 10 times 10 times 10, 10 to the third millimeters cubed in a centimeter cubed. Why don't I put a 1 to the third there? Well, you absolutely can, but we all know that 1 times 1 times 1 is 1, so we're not going to make ourselves confused. Once again, my students want to take these units and start doing math with them. No, the units are there. We have just sorted out their units. Now leave them alone. Don't touch them. Now we just do the math. I'm left here with, let's look, 8.29 times 10 to the third times 10 to the third, which is 8.29 times 10 to the sixth grams per centimeters cubed. Okay? So see what we did differently? The only thing that's happening that's different is right here when we're making this conversion. If it's centimeters cubed to millimeters cubed, we have to cube our conversion factor here. If it was millimeters squared to centimeters squared, we had to square our conversion factor. Let's do one more, and this is the last one I'll do with you unless more problems arise in my own classes. In this one, it's a little bit frightening looking because they are wanting us to go from kilograms per liter to grams per centimeter cubed. And my first reaction might be fear until I remember that in measurement, a milliliter is the same as a centimeter cubed. So you know what I'm going to do? I'm going to cheat and I'm going to convert this to grams per milliliter, and then I know my answer will be the same thing. How will I know that? Because I know this. So recognize that a milliliter is a centimeter cubed, and then you're off. Okay? So here we go. I'm going to convert 1.54 kilograms per liter, 2 grams per milliliter. I've seen students write milliliter cubed. There is no such thing. Milliliter is already a volume, so you don't need to cube milliliter or liter or microliter. It's already a volume. Okay, so here we have kilogram. I'm going to go kilogram to gram. And here we have liter. I'm going to go liter to milliliter. Okay, I can do these. I'm very, very advanced now, and I can do these very easily. Oh my goodness. Would you look at that? The 10 to the third is going to cancel with the 10 to the third, and my answer is going to be the same numeric answer. So guess what, folks? And this is 1.54 grams per centimeter cubed. 1.54 grams per milliliter, or 1.54 grams per centimeters cubed. I hope these 3 videos have helped you. I've tried to include any possible conversion that I see in a standard high school chemistry textbook. If you have any questions, drop a comment below and I will try to address that. Have a good day, and thanks for doing math.